So continuing this lecture series on basic concepts of chemistry, class 11, chapter 1. So today, the topic which we will discuss is about the mole, and I have named this topic as mole, the concept. What is mole? If primarily we can think, the mole is a measurement. Hmm? So measurement at molecular level, atomic level, and particle level. Let's say we consider an element carbon, okay, which has a symbol C. Now this carbon we know has atomic weight is 12 unit, right? 12 unit. Now when we're defining this 12 unit, we are saying that it is C12, which is 12 grams. Okay. Okay. So the next question arises that how many number of atoms are there in this 12 unit of carbon? Okay. So to answer this question, one introduce a particular concept, and that concept is known as the mole concept. So this, when I say mole concept, so primarily I would say that one found that experimentally, if we talk about 1 gram atom, 1 gram atom, okay, and this 1 gram atom contains how many number of atoms that are present in one, how many atoms, okay, and this 1 gram atom of carbon is basically nothing but just 12 units, okay. So this 12 units is particularly is a I would say this is an atomic weight of the carbon. But if experimentally it has been found that in 12 gram, this 12-gram carbon, or this 12 units of carbon, or 12 grams, if I consider 12 grams of C12, C12, this 12 grams of C12 experimentally has been found by mass spectroscopy approximately number of atoms in this 12 grams of carbon. 12 grams of carbon is determined by mass spectrometer. It has been found to be equal to 1.992, okay, 648 into 10 to the power minus 23 grams. Okay, okay. Sorry, this is the weight of one atom. Weight of one atom. Okay, it has been found. So if this is the weight of one atom of C12, one atom of C12, then what will be the number of atoms? Number of atoms will be 12 divided by 1.992648 into 10 to the power minus 23. And you know what is this value? This value is 6.023 into 10 to the power 23. Okay. So what I would say here, so 1 gram atom is basically nothing but 6.023 into 10 to the power 23 number of atoms which contains C12 unit. And this number, okay, so this is atoms per gram, okay, number per gram atom, okay, so per gram atom. Now this number has a very good significance. You know why? Because what Avogadro said, that when we are thinking about the molecules, that the atoms combine to form the molecules, but with this molecule, that two molecules of hydrogen will combine, one molecule of hydrogen will combine with one molecule of oxygen will form one molecule of water. So this small number of atoms, this in 1 gram atom at that atomic level is the 6.023 into 10 to the power 23 atoms per gram atom. But in case of molecules, if you think about this, so 1 gram atom of any element, 1 gram atom of any element is the same as the number of molecules present in 1 gram molecule of any substance is equal to the number of present in the 12 grams of C12. Again, I am saying this one. The number of atoms, the one number of atoms present in 1 gram atom of any element, number of atoms present in 1 gram of any element is the same as the number of molecules present in the 1 gram molecule of any substance, and it is also equal to the number of atoms present in this 12 gram of C12. And how many what is that number is that? That number is basically your 6.023 into 10 to the power 23. And this number is known as the Avogadro's number. Okay, this number is known as the Avogadro's number. Okay, now this Avogadro's number, so this what suggests that this amount of any substance, the amount of any substance which contains 6.023 into 10 to the power 23 number of atoms or molecules is known as 1 mole. So I'm rewriting this statement here. So 1 mole of any substance, I can write here. So 1 mole of any substance contains how much? 6.023 into 10 to the power 23 particles slash atoms slash molecules. So this is the concept of the mole, 1 mole concept. Now the a mole, now if I define a mole is the amount of any substance which contains, the mole is amount of any substance which contains as many elementary entities like atoms or particles or molecules, okay, or ions. It can be ions also, right? And as their atoms have exactly how much is coming, the weight. If you think about, if we take this carbon as a standard, C12 as a standard, the element, right? Carbon exists as C element, okay? So if we take, so the weight will be 0.012, 0.012 kilogram or 12 gram, okay? 12 gram, okay? So, so this kg or this 12 gram of carbon atom gram contains this number of particles as we reduce from here. Now, so this, if we, let's say if I want to define the atomic weight now, atomic weight now. So this scale, this 12, when we are saying carbon is 12 gram, atomic weight is 12 gram. Then what we are saying, the atomic weight, what we are defining is basically on that level. When you have microscopic viewpoint. But when we are saying gram, it looks like we are measuring in a balance, right? But we cannot measure this in a balance because this is atomic level. So we need to build up some connection between our macro world and that micro world. So that connection is built up by this Avogadro number. So during the by defining the atomic weight, what we say, it is 12, not 12 gram, it is 12 gram per mole. When we are saying per mole, that means we are saying that this 12 gram is basically the measurement. 1 mole of C12 has weight 12 gram. Okay, so 1 mole of C12 has weight 12 gram. Or you can say, if let's say if your system defining by kilogram, let's say in your problem you encounter that it is defined by kilogram, then you will say 1 mole of C12, 1 mole of C12 weighs 12 kg. So this gram can be kg, anything you can put. But when you put a mole inverse after this per mole, it goes in that direction. Means it connects you towards a microscopic view. Now, this concept is very much important here because this is built up by the atomic concept. Okay. Now, how many standards are there in your periodic table elements if we talk about? So first, if we talk about the atomic standard, the first atomic standard what we will think in mind is hydrogen. The atomic weight of hydrogen is 0.008 gram per mole. Okay, so the in previously what we defined usually what we defined that the atomic weight is with respect to this hydrogen. That is, it is how much times compared to the hydrogen atom. Okay, but in modern way, what do we define with respect to C12? Okay, now what we say here, how much it is times 1 by 12 of the carbon is basically if the carbon has atomic weight 12, and if I say 1 by 12, so that means it is 1. So basically into 1. So what we are defining by the 112 factor. But there is a reason. Okay. And that reason we will discuss later. Now this C12 is now the current standard way to define an atomic mass of any substances. Now if I say that hydrogen atom so back to our problem that hydrogen contains 0.008 gram per mole. Okay, this is the atomic weight of hydrogen. That means 1 gram atomic mass of hydrogen is basically nothing but 1.008 grams. So this is nothing but the, so 1 gram atom of hydrogen is basically nothing but 1.008 grams. So this is the weight of 1 gram atom of hydrogen. Okay. Now this amount of mass contains 6.023 into 10 to the power 23 molecules. Or sorry, atoms. 6.023 into 10 to the power 23 atoms. Right? This contains 6.023 10 to the power 23 atoms. That means mass of a single atom of hydrogen. Then mass of a single atom of hydrogen is how much? 1.008 divided by 6.023 into 10 to the power 23. So this is what how much coming? Let me check the answer. It is coming 1.67 into 10 to the power minus 24 grams. 10 to the power minus 24 grams. Okay. Now this number is known as the Avogadro number, as I said. So when we are saying define this Avogadro number in several cases, what we use? So this is gram mole inverse, and this Avogadro number has a unit which is per mole, right? Because this is a 1 mole of any substance contains this number of particles. That means when we are defining this number, we have to use this unit per mole. This moles cancel out. This is gram. So this is, see, when we are at calculating the mass of single atom, it is independent of your Avogadro number because you are already dividing with that Avogadro number. So it is independent. Then when the moles cancels out, so basically this will be the weight of a particular single atom, and we are easy now. This is very beautifully we can calculate the single atom. It's the weight of the mass of the single atom of any substances. Like if we calculate the for oxygen, if we calculate. Okay. For oxygen also similarly your how much oxygen atomic weight is 16. CO 16. 16.16. Okay. 16 gram per mole. So what is the mass of one atom is how much? Mass of how much? Okay. It is your 16 by 6.023 into 10 to the power 23. So how much is coming? This is gram mole inverse and this is mole inverse. Mole inverse will cancels out. So the mass is 2.6x, 2.6x into 10 to the power minus 23 grams. So you can easily calculate this one. Okay. So for this is for the this oxygen, hydrogen, for any element like carbon dioxide. Carbon dioxide is a molecule. Water is a molecule. Okay. So for water, carbon dioxide also you can. So 1 mole of water, when I say, that is 18 gram. 1 mole of water 18 gram and it contains 6.023 into 20 power 10 to the power 23 number of water molecules. So this way, for this normal atoms and molecules, you can easily calculate the particular your number of atoms and your uh, number of atoms and number of the weight of the one single atom of the hydrogen. Hmm? Now let's talk about extend this idea a little bit in quite a different case. Okay. Now, as I said, molar mass is also defined. You can, how will you define the molar mass? Gram, mole, and gram per mole, and and atomic mass you define in gram per mole, gram per mole. Okay. The concept is same. Now, if I talk about for gaseous substances, so what is so special about gaseous substances? Gaseous substances. Okay. So what they will have a molar volume in their hand. Molar volume. Okay. Now this, when we are saying the molar volume, that means the number of molecules is here. Number of molecules, what I say, 1 mole contains 6.023 into 10 to the power 23 molecules. Okay, 10 to the power 23 molecules. Okay, now let us consider the temperature is 0 degrees Celsius. Okay, that is 0 degrees Celsius, that means it is 273 Kelvin. Okay, and let us consider pressure is 1 atmosphere. The pressure, 1 atmosphere pressure. Okay, now experimentally it is found that at this condition the volume is 22.4 liters. Volume is 22.4 liters. Okay. Now this, okay. So for any 1 mole of a substance which contains this molecule, 1 mole of any gaseous substance, if we calculate the temperature to 0 degrees Celsius and pressure 1 atmosphere, we will get the volume of the substance is 22.4 liter. And now this volume is known as the molar volume. Molar volume. Okay. So this is the condition. Okay, this condition is known as STP. Full form of STP, standard temperature pressure. Okay, standard temperature and pressure. So this is the concept of the molar volume came. Okay, now in case of, let's say, if I talk about, let's say, ions, if I talk about the ions. Okay, so in case of ions, you have what? Okay, let's write it here. Ionic substances. Ionic substances, if I talk about. So in case of ionic substances, let's say you have a sodium chloride. So we displace this will get sodium plus and Cl minus. That means if I talk about 1 mole of sodium chloride will give 1 mole of sodium ion and 1 mole of chloride ion. Right? That means the 6.023 into 10 to the power 23 contains ions, sodium chloride, gives you 6.023 into 10 to the power 23 number of sodium ions and 6.023 into 10 to the power 23 number of chloride ions. Okay. Now, if I talk about another way, another ion, if I talk about, let's say potassium sulfate, K2SO4. So if you take, so 2K plus SO4 minus 2, right? So 1 mole of K2SO4 now, 1 mole of K2SO4 contains how many molecules? If I talk calculate. So this is 1 mole of K2SO4 means 6.023 into 10 to the power 23 unit. Okay, 6.023 into 10 to the power 3 unit molecules. Okay, molecules. Okay, molecules. So which is equal to, now K plus how many it will produce? 6.023 that means 2 multiplied by 6.023 into 10 to the power 23 K plus SO4 minus how much? 6.023 into 10 to the power 23, right? So how much it is coming? You have to figure it out. It's nothing. So if you add, so this is 2, so this is almost 3 times. 2 multiplied by 1, so 3 times. 3 times of NA. Okay. Right? Okay. Now, this is very easy. Now, if I summarize what I said, if I summarize this, everything what I said, so let's summarize the final, the mole conceptual part. And see, most of the cases you will from this part you will encounter numerical problems, and so those are very easy. Just one thing you have to keep in mind, that this final summarized list what I will make here, keep this in mind, so your everything will be clear. Okay, so when I say 1 mole, okay, 1 mole, this 1 mole means, if I talk about atoms, first what I talk about, okay, so this of atoms, let's say of atoms, so it is what, 1 gram atom, 1 gram atom contains how much? 6.023 into 10 to the power 23 atoms. Okay, now what it led to, what will it give? And the process from 1 gram in mass in grams, the process in grams, this possesses this one. This one, if you convert into the grams, 1 gram, okay, sorry, in grams, mass in gram, and that is known as the atomic mass. Atomic mass, right? Means 6.023 into 10 to the power 23 atoms is nothing but the atomic mass. As I said, the 12 grams of carbon means 12 gram per mole. Okay, so that is 1 mole of carbon weighs 12 grams. Okay, next one. If we talk about, let's say, molecules, okay, so of molecules, so 1 gram molecule contains 6.023 into 10 to the power 23 molecules, and which one, and that will lead up to molecular mass. right? Next, which one? This one, of an ionic compound, of an ionic compound, if I talk about. Okay, so it will contain 6.023 into 10 to the power 23 units, right? And this will lead you to formula mass. Now, why formula mass? Because these ionic compounds are known to have a close pack structure. So that this, due to this close pack structure, they don't have a particular molecule, because the atoms are arranged in a different fashion, close pack structure. Okay, so what they have is basically their formula mass. They don't have particular molecular mass. Okay, and the last one, for a gaseous substance we talk about, for a gas at STP, for a gas at STP, if we talk about. So this is what, 22.4 liter, and that will give you what, molecular mass. Okay, so if you remember this table very clearly, it will be very easy for you to understand the mole concept, and it is very easy. And this is not made by me. This is taken from the Nutan chemistry. Okay, and it's very beautiful. I thought I would show you that to give you a good representation. Okay, so that's all from the mole concept. Now, please check that now next video. What I will talk about, that how to determine the molecular mass of different substances by different methods. Okay, I will not go to the methods in detail, but I will give a glance at the working formulas which you use for the calculation purpose. Okay, so till then, happy mole.